On this channel, we provide useful programming information with practical code examples. This time, the topic is TypeScript in IndexedDB. We will explain TypeScript and IndexedDB with practical examples. Enabling subtitles will make the code descriptions easier to understand. IndexedDB is a low-level NoSQL storage that allows you to persist structured data in the browser. With TypeScript, you can represent schemas in a type-safe way, reducing errors and improving maintainability. IndexedDB is a small database inside the browser. It manages data using mechanisms such as databases with names and versions, object stores, transactions, indexes, and cursors. Databases have versions, and when the version is upgraded, an upgrade needed is called to update the schema, such as creating or modifying tables. First, we show an example of opening a database with IndexedDB and creating an object store in an upgrade needed, if necessary. This code opens the database and logs whether it succeeded or failed. If needed, the TODOS store is created in an upgrade needed. When actually running this code, it must be done within an HTML file. In this video, we only check that there are no compilation errors. Next, we define data types using TypeScript. This ensures type safety in subsequent CRUD operations. Here, we define the to-do type. Next, we show basic CRUD operations such as adding, retrieving, updating, and deleting from the object store. Each function takes an IDB database and returns a promise. This function adds a new to-do to the TODOS store in IndexedDB. It returns a promise for asynchronous handling, which resolves when processing is complete. This function retrieves the to-do with the specified ID and returns the object if found. If no matching data is found, it returns undefined. This function updates existing to-do data. On success, the ID of the updated to-do is logged. This function deletes the to-do with the specified ID. When processing is successful, the deleted ID is logged. These functions resolve or reject a promise depending on transaction completion or errors. Including output via console.log, makes it easy to track what is happening during execution. By using indexes in IndexedDB, you can efficiently search on specific fields. Here, we create an index for created at and give an example of a range query. This function opens the database and creates or verifies the by created at index on the created at field. This allows for efficient searching and sorting by creation date. This function retrieves only to-dos created after the specified timestamp. Using the index allows efficient data scanning in creation date order. In this example, a by created at index is created during the database upgrade, and to-do items created after the specified time are enumerated with a cursor. The low-level IndexedDB API is complex to write, and repeated similar operations can lead to redundancy and bugs. Therefore, by preparing a generic TypeScript wrapper class that abstracts the operations, we improve code simplicity and maintainability. Below is an implementation focused on basic functionality. This class wraps IndexedDB operations and provides type-safe CRUD methods. It assumes an object store where the key is ID. It opens the database and creates a new object store if necessary. Store initialization is performed using the upgrade event. Adds data to the IndexedDB store. After adding, the ID is logged to the console. Retrieves data corresponding to the specified ID. Undefined is returned if the data does not exist. Updates existing data or adds new data. After processing, the updated ID is logged. Deletes the data with the specified ID. On success, the deleted ID is logged. Retrieves all data in the store. The return value is an array of type T. This code is an actual usage example of the IDB wrapper class. This shows the flow for adding, retrieving, updating, listing, and deleting to-do data. This wrapper allows simple handling of basic CRUD operations. In a real-world environment, you also need to handle error handling and schema management, indexes. To change the database schema, increase the second argument, version, of IndexedDB. Open and update it on upgrade needed. You need to design it so that existing transactions have finished and destructive changes are avoided. Heavy processing inside, on upgrade needed, can block the UI, so keep it to a minimum, and consider delayed migration, staging processing during app startup, if possible. Transactions are automatically committed before execution of the script that created them ends. When using await inside a transaction, it may be committed unexpectedly. Caution is needed when performing multiple async operations within the same transaction. Be aware of transaction lifespan. Use separate transactions if necessary, or schedule operations synchronously within a transaction. By using a cursor, you can process large-scale data sequentially or implement simple pagination without using offsets. By fetching items one by one with cursors, memory usage can be reduced. When implementing paging, it is common to remember the last read key. IndexedDB may not be available due to implementation differences between browsers or users' privacy settings, such as private browsing. Therefore, check whether IndexedDB exists and, if not, provide a fallback such as local storage. IndexedDB is fast and powerful, but performance can vary greatly depending on its design and how data is handled. Depending on the use case, optimization can be done in the following ways. Design the object store according to the actual usage. For example, if there are many reads, provide indexes. If there are many writes, keep the key design simple. Large binary data such as images and audio should be stored as blobs, or managed using the file API or service workers if needed. Compression can also be considered if necessary. Keep transactions as short as possible and perform heavy processing outside the transaction to minimize lock time. Indexes can speed up searches, but slow down inserts and updates, so create only those that are truly necessary. When dealing with many small pieces of data, retrieving them all at once using get all may exhaust memory. You can reduce memory usage by splitting the processing with cursors. IndexedDB data is isolated per domain and protocol according to the same origin policy. Design under the assumption that data may be lost if users delete browser data or use private mode. To use IndexedDB effectively with TypeScript, it is important to prepare types and asynchronous processes, be aware of version management and transaction design, and wrap common processing to improve maintainability. The source code for this video can be downloaded from the official website. If you like, please visit the URL in the description to aid your learning. I hope this video helps improve your programming life. By subscribing to the channel, we can deliver more useful information to you.